next program is to print diagonal elements. That is, I want to print main diagonal elements trace. Trace is nothing but it is sum of main diagonal elements. Trace is nothing but sum of main diagonal elements and normal of a matrix. Normal. So what is normal is, it is square root of sum of squares of matrix of sum of squares of individual elements of matrix. So we call it as normal. So there are three problem statements in the given program. The first problem statement is we need to find the diagonal elements, and the second problem statement is we need to find the trace of a matrix. So trace is nothing but it is sum of main diagonal elements, and the last test case within this particular problem statement is normal of a matrix. Normal is nothing but it is a square root of sum of squares of individual elements of matrix. So we'll be seeing these in detail. So here we require hash include stdio.h standard input output header file, and we also require math.h because here we are using square root function. So here matrix, I am initializing the variables int matrix of 3 by 3, rows, columns I, j, and sum equal to 0. Initially I am taking the sum value as 0 because I want sum, right? Next I am taking normal as a variable. Next, reading the size of matrix. So this you anyhow know it because we have seen in the previous program. So I am trying to relate with the previous program because it is very much easier to remember and very much easier to write the piece of code. So that is the reason I am not changing any identifier names. I am putting the same identifier names. If you want, you can change different identifier names for the different programs. It doesn't mean that it works only for R and C. You can write rows, you can write columns, you can write a row, you can write call, something. So it depends upon your understanding. Okay. Next, read the elements in the matrix. So this is how we are going to read the elements in the matrix. This anyhow you know it. Next, coming to printing the diagonal elements of a matrix. In the earlier case, we have seen for lower triangular matrix, upper triangular matrix. For upper triangular matrix, if I is greater than j, we are going to print the upper triangular matrix. If I is less than j, then we are going to get lower triangular matrix. Here, if I is double equal to j, then we are going to print the diagonal elements. What do you mean by I double equal to j? If I am considering a matrix of size 3 by 3, the first element's index is 0, 0. Next, the second element is 0, 1, 0, 2. Next, second row 1, 0, 1, 1. So you can see here 0, 0, 1, 1 and 2, 2. 0, 0, 1, 1, 2, 2 is called as the diagonal elements. That is main diagonal elements. Now I am going to print those diagonal elements. Why am I using this else is because the third element should give with the 2 tab spaces. So that is the reason for exactly printing the diagonal elements we are using this if else logic. Next, so after printing the diagonal elements, I want trace. Trace is nothing but it is the sum of diagonal elements, sum of main diagonal elements. So in order to get the sum of main diagonal elements, here we have used I double equal to j. Now I double equal to j, here sum is equal to sum plus matrix of ij. Sum is equal to sum plus matrix of ij, which means I will be getting only the sum of diagonal elements, because here I have given the index, that is I and j values when they are equal, double equal to sign. I think you remember this double equal to sign, which comes under relational operators, LHS equal to RHS. When both I and j values are equal, only then this particular statement should be executed. That is what if condition. If the condition is failed, then it is not going to execute, or then it is not going to add to the sum. So this is how we are printing the sum of main diagonal elements. Next, normal of a matrix. So what do you mean by normal of a matrix is, normal of a matrix is square root of sum of squares of individual digits of a matrix. Square root of sum of squares of individual elements of a matrix. That we are going to call it as a normal of a matrix. So here again I am reinitializing sum value equal to 0, because in the same program I got this sum value over here. So I should not get this sum mixed up with the normal of a matrix. That is the reason I have reinitialized this sum value to 0. Now for I equal to 0, I less than R, I plus plus. For j equal to 0, j less than C, j plus plus. Here I need to get sum of squares. So in order to get sum of squares, so this is the statement. So this is the instruction what we are going to write to get the sum of squares. So matrix of ij, that is in 0, 0th location, whatever the value you have, the two values will be multiplied, that is square. If imagine there is a number 5, so 5 into 5, 25 will be added to the sum. That is what we require, sum of squares. So this particular line, this particular instruction whatever we have written here, this will give you sum of squares of a individual elements of matrix. Now after getting sum, we need to get normal. In order to get normal, we need to square root. SQRT is the inbuilt function which is being supported by math header file. Now SQRT of sum, whatever the sum you get it, that will be square root, and you are going to get the normal of the matrix, that we are going to print it. So this is how we can execute these three problem statements, that is diagonal, trace as well as normal. Let us execute this and see the output for each. Now let us execute this and check. Enter the size of matrix. So here I am giving the size of matrix as 3 by 3. Now I am giving the elements 1, 2, 3, 4, 5, 6, 7, 8, 9. So don't think that only for these numbers this will be applicable. You can give any numbers. Just for our easier understanding, I am giving these numbers. The diagonal elements of a matrix are, that is 0, 0th position, 1, 1 position and 2, 2 position, right? So in order to print in this fashion, that is exactly according to the matrix diagonal position of the elements, so we have used this if else. This is the reason why you are getting this diagonal matrix elements according to its positions, right? 0, 0, 1, 1 and 2, 2. Now what is the next one? Trace of the matrix. So the sum of main diagonal elements are 15. So 1 plus 5 is 6, 6 plus 9 is 15. So we got the result as correct result. Next, normal of the matrix. Perform 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, 9 square. So you're going to get a result, right? That sum you just square root it. If you square root it, you get 16. Right? So this is how we are going to get the diagonal elements and sum of the diagonal elements called trace as well as normal of any given matrix. I hope every one of you understood it.